The James Webb Space Telescope recently captured an image of a galaxy that existed 13.5 billion years ago, just 300 million years after the Big Bang. And when scientists at NASA's Goddard Space Flight Center analyzed the data, they found something that shouldn't exist. A galaxy that old, that massive, that structurally developed, violates our current models because the universe wasn't supposed to organize itself that quickly. What keeps me thinking about this late at night is a simple question, and that question is this. If our models are wrong about how fast galaxies formed, what else have we gotten wrong? When you genuinely understand how old this universe is, and I mean truly understand the weight of it rather than just the number, you realize that your conception of time is fundamentally broken and your brain wasn't built for this kind of understanding, which I mean in the most literal neurological sense. Consider your own age for a moment. 30 years, 50 years, maybe 80 if you're lucky. You think that represents a meaningful stretch of existence, and I need to tell you directly that you have no idea what old actually means. The number of years any human has ever lived rounds to zero on a cosmic scale. And I don't say that to make you feel small, but rather to expand your understanding of your place in existence. When you wrap your mind around the true depths of cosmic time, you don't shrink, and instead you become connected to something so vast and so ancient that it changes what existence itself means. The problem is that your brain genuinely cannot process this information, and that's not a figure of speech, but rather neuroscience. Your hippocampus, the seahorse-shaped structure responsible for forming memories and your sense of time, evolved for tracking seasons and generations across maybe 100 years at the absolute maximum. Your neural architecture took shape on the African savanna, where our ancestors needed to track predators, remember water sources, and anticipate when the rains would arrive. We developed a sense of time calibrated for survival and reproduction, not for comprehending billions of years. When I tell you the universe is 13.8 billion years old, your brain slides right off that number like you're trying to grip a wet marble. The information enters your consciousness, but understanding doesn't automatically follow, which means you have to work for it and build up to it layer by layer. Let me take you to a specific moment in history. The year is 1929, and we're standing at Mount Wilson Observatory in California, home to the Hooker telescope, which was the largest telescope on Earth at that time. An astronomer named Edwin Hubble is about to shatter everything humanity believed about our place in the cosmos through his observations of fuzzy patches of light that astronomers had argued about for decades. The question was whether these patches were nebulae, meaning clouds of gas, within our own Milky Way, or whether they represented something else entirely. Before we give Hubble all the credit, which is what everyone does, you need to know that a Belgian priest and physicist named Georges Lemaitre had already published the mathematics 2 years earlier. Lemaitre used Einstein's equations of general relativity and concluded that the universe must be expanding, and Einstein himself told Lemaitre that his physics was correct, but his conclusion was abominable because Einstein wanted a static, eternal cosmos. Einstein turned out to be wrong on this point, and Lemaitre turned out to be right. But Hubble got the telescope access, the observational evidence, the fame, and eventually had NASA name a space telescope after him. Science history is messier than the textbooks admit. What Hubble observed through the Hooker telescope confirmed that those fuzzy patches weren't gas clouds at all, but entire galaxies, each containing hundreds of billions of stars. These galaxies existed outside our Milky Way, and every single one of them was moving away from us in every direction. The farther away a galaxy was, the faster it receded from us. And that pattern tells us something profound about the past. If everything is moving apart right now, then at some point in the past, everything must have been together. Running the clock backward compresses all those galaxies, all that matter, and all that energy back further and further until you reach a point of density beyond imagination, a point where space itself began. This wasn't an explosion happening inside space, but rather an explosion of space marking the beginning of time itself. The term Big Bang was actually coined by astronomer Fred Hoyle in 1949, and he intended it as a dismissal. Hoyle championed the steady-state theory, which held that the universe had no beginning and had always existed in its current form, and he considered the concept of a cosmic origin to be absurd, almost religious in its implications. The evidence that accumulated over the following decades buried his theory completely. The precision with which we know this happened 8 billion years ago, comes from measurement rather than estimation. NASA's Planck satellite, which the European Space Agency launched in 2009, measured the age at 13.799 billion years, with a margin of error of just 21 million years, representing an uncertainty of only 0.15%. In the field of cosmology, that level of precision is extraordinary. Before Planck came NASA's WMAP satellite, which narrowed down the estimate considerably. And before WMAP came the COBE satellite with the first detailed measurements. Each generation of instruments refined the number further. And this accumulated measurement constitutes science rather than guesswork. A faint glow permeates all of space, and this glow represents the oldest light in the universe, known as the cosmic microwave background radiation. Let me give you the precise specifications of what you're dealing with here. These photons last interacted with matter when the universe had a temperature of approximately 2,970 Kelvin, which was hot enough to ionize hydrogen completely. They've traveled roughly 46 billion light years through expanding space, covering a distance greater than the universe's age because space itself stretched during their journey. They arrive at our instruments redshifted by a factor of 1,089, meaning that what began as visible light in the orange-white blazing spectrum has been stretched by cosmic expansion into microwaves. These numbers come from measurements taken by the COBE, WMAP, and Planck satellites, rather than poetic approximations. When you tuned an old analog television to a channel with no signal and watched that static snow filling the screen, about 1% of that noise consisted of this ancient light. You were watching the afterglow of creation itself, the universe's baby picture captured when the cosmos was only 380,000 years old. That number, 380,000 years, sounds like a considerable stretch of time, until you calculate that it represents less than 0.003% of the universe's current age. Before that moment, the universe existed as a hot, dense fog of plasma, where photons couldn't travel freely because they kept colliding with free electrons. The universe was opaque during this period, like being suspended inside a cloud with no visibility in any direction. Expansion gradually cooled everything down until electrons combined with protons to form neutral hydrogen atoms, and suddenly light could travel unimpeded. The universe became transparent, and the light released at that transition moment has been traveling for 13.8 billion years in every direction, finally reaching our instruments today. Scientists call that transition recombination, even though it was really the first time those particles ever combined. Let me give you a way to feel this, because numbers alone won't create the understanding you need. My predecessor in science communication, Carl Sagan, developed something called the cosmic calendar, and I've continued using it because nothing else works as effectively. Imagine the entire history of the universe compressed into a single calendar year, with January 1st at midnight representing the Big Bang. And right now, this moment, as you're listening, landing on December 31st at the stroke of midnight. One complete year on this calendar represents 13.8 billion years of cosmic history. The Milky Way galaxy doesn't form on this calendar until around March, and our solar system, including the sun, Earth, and everything we call home, doesn't coalesce until early September. Life appears on Earth remarkably quickly, within a few weeks of September. But that life stays simple for most of the remaining months, consisting of single cells and nothing more complex. Complex multicellular life doesn't emerge until mid-December, and dinosaurs don't appear until December 25th, Christmas Day on the cosmic calendar. They dominate until December 30th, when the Chicxulub asteroid, which scientists have now located in Mexico's Yucatan Peninsula, ends their 165 million year reign. Modern humans, people who look like us and think like us and dream like us, show up on December 31st at approximately 11:52 p.m., which is 8 minutes before midnight. Everything about our species fits in those final 8 minutes of the cosmic year. Recorded history, including writing, agriculture, cities, and civilization, occupies the last 14 seconds of December 31st, meaning that every event you've ever read about in a history textbook happened in those 14 seconds. The pyramids of Giza rose about 7 seconds ago on this scale. The Roman Empire existed for roughly 3 seconds total. Columbus reached the Americas less than 2 seconds ago. The Declaration of Independence happened about 1 second ago. Both world wars, the moon landing with Neil Armstrong and Buzz Aldrin stepping onto lunar soil while Michael Collins orbited above the invention of the internet, and the smartphone in your pocket all occurred in the final fraction of a second. Here's something that nobody tells you about the cosmic calendar. Your brain physically cannot register those 14 seconds as the insult to human importance that they actually represent. When I say 14 seconds, your hippocampus processes that duration as brief, almost insignificant. And when I say 8 minutes, that registers as trivial. But mapped onto 13.8 billion years, those 14 seconds contain the rise and fall of every empire, every philosophical system, every war, every love story, and every piece of music ever composed. The neural architecture that would allow you to genuinely feel that compression doesn't exist anywhere in your skull, we are neurologically imprisoned within human scale time, unable to escape our evolutionary limitations. When you look up at the night sky, you're seeing the past rather than the present moment. Light requires time to travel across the distances involved. and the spaces between objects in the cosmos stretch so incomprehensibly vast that light, the fastest phenomenon in existence at 186,000 miles per second, can require millions or even billions of years to complete the journey. The Hubble Space Telescope, named after that astronomer from 1929. And now the James Webb Space Telescope have spent decades measuring these distances using Type Ia supernovae as standard candles, which are explosions of such predictable brightness that scientists can calculate their distance based on how dim they appear from Earth. Proxima Centauri, the nearest star to our sun, sits about 4 light years away, meaning the light you see from that star departed 4 years ago, and you're observing that star as it existed in the past, rather than as it exists right now. The Andromeda Galaxy, the nearest major galaxy to the Milky Way, and part of what astronomers call the local group, lies 2.5 million light years distant. When you observe Andromeda through a telescope, you're seeing light that departed when our ancestors were just beginning to use stone tools, back when Homo habilis was chipping rocks together. That ancient light is only now completing its journey to Earth. Every telescope functions as a time machine because looking deeper into space means looking further back in time. The James Webb Space Telescope, positioned at the L2 Lagrange point, 1 million miles from Earth, now captures images of galaxies from when the universe was less than 5% of its current age. We're observing cosmic infancy and watching for signs of the first generations of stars, which astronomers call population 3 stars. Though scientists haven't definitively confirmed seeing them yet because that remains one of Webb's primary missions. Here's what all of this means for you personally. Every atom in your body, including every carbon atom, every oxygen atom, every nitrogen atom, calcium atom, and iron atom, formed in the heart of a star that lived and died before our solar system existed. The same spectroscopic fingerprint that reveals iron in a distant supernova remnant matches the iron circulating through your blood. We don't believe you're made of stars based on poetic intuition. And instead, we can prove it the same way forensic scientists prove DNA at a crime scene. You don't merely exist within the universe because you are made of the universe itself. The calcium in your bones formed when massive stars, at least 8 times the mass of our sun, exploded in supernovae billions of years ago. Vera Rubin's work on dark matter revealed that there's even more universe than we can see directly. But the ordinary baryonic matter composing your body originated in stellar forges scattered across the cosmos. Those atoms coursing through you are ancient beyond comprehension. The hydrogen in your body, which constitutes about 10% of your mass, formed during the Big Bang itself, making those hydrogen atoms 13.8 billion years old. They've existed since the beginning of everything that exists. They've drifted through cosmic voids, gathered into molecular clouds, collapsed into protostars, been blown outward by stellar winds, incorporated into planets, cycled through oceans and atmospheres, and eventually ended up arranged into you. You carry atoms that have witnessed the entire history of the universe. Here's a thought experiment that can help you feel cosmic time in human terms. A single penny invested at 5% interest at the moment of the Big Bang would now be worth more money than atoms exist in the observable universe. That's mathematics rather than metaphor. Compound interest stands as one of the only human-scale systems that even approaches cosmic timescales. And it takes the Big Bang to make interest rates produce absurd results. The sun has existed for about 4.6 billion years, roughly 1/3 the age of the universe, and Earth formed shortly afterward from the same spinning disk of gas and dust about 4.5 billion years ago. Scientists have recovered zircon crystals from Western Australia, dated to 4.4 billion years old, nearly as old as the planet itself, and those crystals serve as physical receipts of deep time that you can hold in your hand. Life appeared on Earth remarkably quickly, within the first billion years. But for most of Earth's history, life remained simple. Single-celled organisms dominated for roughly 3 billion years, and complex multicellular life didn't emerge until about 600 million years ago during what scientists call the Cambrian explosion. Dinosaurs appeared around 230 million years ago and dominated for over 165 million years until an asteroid ended their reign 66 million years ago, giving mammals, those small, furry, previously insignificant creatures, a chance to diversify and eventually produce us. Modern humans have existed for roughly 300,000 years, representing 0.007% of Earth's history. The dinosaurs ruled this planet for more than 500 times longer than humans have existed, and yet we carry the audacity to believe we own the place. The sun will continue burning hydrogen for another 5 billion years or so, and when it exhausts that fuel, it will swell into a red giant, expanding outward to consume Mercury, consume Venus, and possibly scorch Earth into a cinder. After that expansion, it will shed its outer layers and leave behind a white dwarf, a stellar corpse roughly the size of Earth, but carrying the mass of the sun, gradually cooling over trillions of years. The universe will continue without us, and other stars will form from the debris of our sun's death, and other planets might coalesce around those new stars. The cosmos operates with patience on scales that make human civilization appear as brief as a camera flash. But here's what remains beautiful about all this. You exist right now, in this sliver of cosmic time, on this pale blue dot, to borrow Carl Sagan's description, orbiting this ordinary yellow dwarf star in the Orion arm of this average spiral galaxy. In a universe 13.8 billion years in the making, you are here. You possess the capacity to look up at the night sky and ask questions about where everything came from. You can feel the weight of billions of years pressing down on this present moment. No other species on Earth does this, as far as we can determine. Scientists have searched the skies for signals from other civilizations through the SETI project, the search for extraterrestrial intelligence, and the result has been silence. The Fermi paradox haunts this search with a simple question. In a universe this old, where is everyone else? Maybe we arrived early in cosmic history. Maybe intelligence is rare. Maybe consciousness represents the universe's way of knowing itself, and maybe that doesn't happen as often as the numbers might suggest. Every time you look at the night sky, you're observing time itself rather than just stars. Ancient light has crossed unimaginable distances to reach your eyes, and through those photons, you connect to events that occurred billions of years before Earth existed. Every atom in your body links you backward through cosmic history, through the deaths of ancient stars, through the expansion of space, through the formation of galaxies, all the way back to the first moments of existence. The universe is 13.8 billion years old, but that number isn't really the point. The point is that you're part of it. The hydrogen atoms in your body, remember the Big Bang? The carbon atoms, remember the star that forged them? Your consciousness emerged somehow, improbably, from matter that has been on the 13.8 billion year journey to become you. That's what the age of the universe actually means. It's not just a number and not just billions of years scrolling past comprehension. It's the story of everything that ever existed, written into the matter, composing your body, illuminated by the light filling the sky, measured by instruments that humanity built to ask questions. The universe never required us to ask. We are the cosmos made conscious. We are the universe looking back at itself and wondering how old it really is. And knowing that changes everything about how you see your place in existence.